Sorry, I meant to record, but now um, those of you watching this won't get to see the chat. But in the chat, I have written these formulas that sort of summarize, sort of break down the two possibilities for a game, for a two-player game. For a two-player game, either you're getting more than me, or I'm getting more than you, or it's the same. Those are the only possibilities. And the first thing I wrote is the case where xj, that's you, is greater than xi, that's me. I feel envy, that's why I used alpha. In the second line, I wrote xi greater than xj. And if you look inside the parentheses, you might see how I flipped. I didn't say xj minus xi anymore because in the second line, I'm getting more than you. So I wrote xi minus xj. That flip there is kind of subtle, but it's important for you to notice that. So these are the formula that you can use to answer the homework questions that are currently available to you on Blackboard, and they're due by next class Monday. And why did I do this? It's to give you practice. Most of what we learn in this class isn't very quantitative. It's mostly about, you know, applied psychology to economics. And there are these phenomena that I want you to know about, and not so much like just math. But this is the first one where it really is just math. I'm testing to see if you understand how to use a rational choice model based on a utility function. And so the homework is giving you practice, calculating utility, and okay, so that's questions 1, 2, and 3 in the homework were about that. In 4 and 5, questions 4 and 5, those are a bit harder because you're not just plugging and chugging into the utility formula. Here's how I want to help you now. You came to class. If you're listening to me right now, you will get this information, and hopefully it will help you answer this homework problem for numbers 4 and 5. They are questions of what is optimal. And you, hopefully, you're an economics student. You know what it means to be optimal. But in a rational choice model, what does it mean? It means you're maximizing your utility. That's what that means. I'm choosing the optimal thing, which means I'm maximizing my utility. Okay, and in question 4 and 5, I'm asking you again about the trust game, but I'm flipping it around now. And I'm not talking about the second player, I'm talking about the first player. I'm talking about the first player that says, okay, hopefully you know what the trust game is, but in the first player has to decide. They both start out with $10. In this game, they both start out with $10. So it's a pretty good deal for the second player because at least they're going to get that $10 that they start out with. They might get more, and that is if the first player sends some of their $10 to the second, it gets tripled. Whatever they send, it gets tripled. So now I'm asking for the perspective of the first player, what is the optimal amount of dollars to send to the second player? How will you calculate that? Well, use what you know about the behavior of the second player using the Fair-Schmidt utility functions. In fact, it's the exact same functions that I'm telling you about in questions 2 and 3. So this sort of builds on questions 2 and 3. I'm very familiar with these questions because I just wrote them yesterday. In questions 2 and 3, I'm giving you the perspective of the second player. What would be my utility if I did this? What would be my utility if I did this? You can use that information though. Learn from that what the second player would do. And then go back to the first player and say, well, what should the first player do, knowing something about the behavior of the second player? So in questions 4 and 5, I ask, oh, what do? I change the alphas and the betas. Yeah, I'm a little tricky this way. So in question 4 and 5, the only difference is I basically swap the alpha and beta parameters of the two players. So player one and player 2, they're two different people. They're allowed to have two different alphas and betas. I didn't have this in the formula. So If you look in the paper, it says alpha subscript I. I should have done that for completeness. Do you guys get why the formula, it makes more sense to say alpha sub I? It's because each player could have their own alpha. Don't you agree? This is the point of a parameterization, is to say each person who's playing this game, they may feel differently about envy or about guilt. And we account for that by saying they're allowed to have different alphas or different betas. So in problems 4 and 5, that's what I do. I say, well, in problem 4, here are the alphas and betas of player 1. Here it is for player 2. Now tell me what the best thing for player 1 to do is. And here's my hint. I've done all of this is just to describe the problem. Now I can, give you a hint for how to solve it. The first thing you should do is think about what would player 2 do. So look at player 2's parameters, their alpha and their beta, and figure out, given some sort of money from player 1, how much would they return? Really try to think about that. And in fact, you will have just thought about that in questions 2 and 3. But use that information to think about what would player 2 do almost as a response to player 1. And if you've thought about that, you know exactly how player 2 would respond to player 1. Then think about what player 1 would do. Of all the actions player 1 can do, which is to send money, they either can send $10 or $0 or something in between 10 and 0. Think about, for each amount of money that they send, how much would they be getting back? And try to maximize that. Try to think about what's the best player 1 could do. Does that make sense? And that's how you can answer those problems, the last 2 problems in the homework. Does anybody have any questions about that? I think I'm giving you hints without actually telling you the answer, because I want you to try and do it yourself. But I don't want it to be confusing. If you look at the problem and say, I have no idea what he's even asking me to do, that's a problem. That means you're not understanding the material, which you should ask about now, because I can help with that. But if no one has any questions, I say we just go on, because I think I've said all that I want to say about inequity aversion. It's not the most important model in the world. It's just a model. I picked it to teach it to you because I myself have used it before. Why not teach it to you? I've used different models too. I've used one by, what's his name? Jim Cox. He's a very distinguished economist, and I've used one of his models because it was suited my purposes at the time. Okay, you guys have any questions? Let's go on. Next thing I want to talk about isn't inequity aversion. It's more about game theory. So maybe there'll be some more numbers even. But you may say, well, haven't we already talked about games? What is a game? What do you mean? Are you talking about chess or checkers or tic-tac-toe? Well, technically, yes, those count as games, but that's not what economists mean when they talk about games. A game is any situation where more than one player, so it can't just be you playing alone. Solitaire is not a game, according to economics. More than one player has a set of actions that they can take, and they can choose from. It doesn't just happen to them. It's not a game if you just, I actually think the game Candyland, do you know Candyland? You just draw, and then you draw and you draw. That's actually not a game, according to economics. You have no choice. You have no action space and strategy space, because everything is predetermined by the shuffling of the deck when the game starts. The game starts with the shuffling of the deck It gets put down, and from then on, everything else is predetermined. That's actually a good metaphor for some sorts of philosophy, whether we have free will or predestination. I read a philosophy comics. Oh, it's existential comics or something like that. It was about that, and one of the philosophers argued, actually, you do have a choice in Candyland. Your choices are play the game or don't, walk away. I thought that was a good comment. Anyways, a game has to have more than one player. It has to have some choices that you're making, some actions that you can choose from. And there has to be some mapping of actions to payoffs. And generally, there's some interdependence of payoffs. What does that mean? What I do affects your payoff, and what you do affects my payoff. It can be in some trivial way, like the dictator game. The dictator game is technically a game because my choice as the dictator affects your payoff. You happen to have no choices to make as the recipient. You just sit there and accept what happens. Technically, it's still a game because at least one of the players has a choice to make, and it affects more than just their own payoff. It affects the other person's payoff. So that's like the simplest possible game is the dictator game, but it counts. We've talked about other games, the ultimatum game, public good games, prisoner's dilemma game, coordination games, and the other ones? Oh, the gift exchange game and the trust game. All of those are games according to the economic definition of game. So you've already had some quote unquote game theory that we've talked about in this class, but all of those games have something pretty simple in common, which is that the strategic elements of the game are so straightforward that it boils down to almost a personal belief or a personal choice. For example, let's take the gift exchange game. Really, you're thinking about how much do I want to give back to this person. There's not a lot of strategy involved. Not a lot of, wait, I got to think about what that other person will do. You would admit that's a good term for strategy. Even, excuse me, I'm sorry, I'm having some indigestion or something. But this is what we mean when we talk about strategy. How strategic are you being? It refers to how much are you thinking about what the other person will do and how you will respond either preemptively or in succession afterwards to what the other player does. In most of the games we've talked about so far, there's no need to be very strategic because they're more about payoffs and fairness or reciprocity or cooperation, things like that. Prisoner's dilemma game, actually, there is some strategy, right? Because if you're a conditional cooperator, this is a good aside. If you're a conditional cooperator, actually it matters what you think the other player will do. If you think they'll cooperate, you should cooperate too. If you think they will defect, you should defect also. But we'll call those beliefs. So formally in game theory, a belief is what you think the other player will do. Actually, those are called first order beliefs. A second order belief, and just to let you know, is how you think the other player thinks you will play. That matters too, right? If I think that you think I'm going to play as a defect, I'm going to defect. And I also think that you're a conditional cooperator. In other words, you will cooperate with me if you think I'm going to cooperate. You will defect against me if you think I will defect. And not my first order belief, but my second order belief is that you think I will defect. Then actually, even if I'm a conditional cooperator, I want to cooperate with you, and you're a conditional cooperator, you want to cooperate with me because of these second order beliefs, we'll end up both defecting, right? Okay, so game theory has this very complicated ordering of beliefs and information. Like Do I know what you're going to do? Do you know that I know? Do I know that you know that you know? I know. Have you ever seen The Princess Bride? There's a great scene there with Vicini, the Sicilian short bald guy who's kind of the sinister person who kidnaps the princess, and Wesley, aka the Dread Pirate Roberts, aka the Man in Black, is trying to save Princess Buttercup from Vicini, the Sicilian guy, and he says, "I challenge you to a battle of wits." And they have the battle of wits. They sit down at a rock or a table somewhere and pour two glasses of something wine, and the Man in Black puts iocane powder in one of the two, or at least that's what he says. And then they have this game of do you drink the one in front of me or the one in front of you? One of them's poisoned. You have to decide which one it is, and then whoever wins, whoever loses will die. Whoever wins will, I guess, get control of the princess. I don't whoever wins. Uh, anyways, it's a game of not just rationality, but several orders of rationality. What do I have a? I have to think about what a rational person would do. Then I have to think about what somebody who's expecting the other person to be rational would do. Let me just extend this metaphor a little bit more. I usually talk about The Princess Bride, but I'm talking about it a lot right now because I feel like it. In The Princess Bride, the first thing Vicini says that any rational person would not put the poison in front of them because they'll die if they drink the poison in front of them, so they would put it away. But anybody who's expecting that the other person thinks that they're rational would do the opposite of that, because they would expect that their opponent was predicting that they would put the poison away from them, so they should actually put the poison right next to them. And of course, Vicini goes on these multiple rounds of logic to try to think. It's actually pretty accurate in terms of how game theory is set up in terms of higher order beliefs, first, second, third, fourth, all the way to maybe common knowledge of rationality is the ultimate case where everybody knows that there's common knowledge of rationality. Okay, by the way, in the game, Vicini tries to trick Wesley, say, "Oh, look over there." And Wesley looks and he flips the poisons, and then he grabs one to drink the poison to try to get Wesley to reveal something about whether it was. And having thought that he tricked Wesley, he drank the cup. Turns out Wesley was immune to the powder. They were both poisoned. Anyways, long story. Oh, I just ruined The Princess Bride for you. Sorry about that. But that has many other great game theory interactions in that movie. So watch it if you like game theory. Or if you just like classic movies from the 80s, starring Fred Savage, Cary Elwes, and Robin Wright Penn. Okay. Let's talk about rationality, because that's what this lecture is really about. I have a little stuff I can share. Yeah, let's think about thinking strategically. I decided this could be our first example of a game where it really matters to think strategically, and it's called the Game of Chicken. By the way, there's another 1980s movie that has an example of the Game of Chicken, different game, but the example is Footloose, where Kevin Bacon is driving this tractor towards another guy who's from this town, who's driving a tractor towards them. And the way this game of chicken is played, the first person to swerve is the chicken, is the loser. Okay, and so just to explain the game of chicken, what is the optimal thing to do in the game of chicken? Well, it can't be that you should never swerve, because if both players never swerve, then they crash into each other and they perhaps both die. Who knows what happens when two tractors run into each other at top speed? But that's what's portrayed in the movie. That's what's about to happen. So it can't be that you should always, that you always just don't swerve. Well, what about swerving? Well, if the other guy's going to swerve, then it's not good for you to swerve either. You could go straight and win the game and make the other guy look like the chicken and you win. So what's the best thing to do in the game of chicken? It depends on what the other guy does, right? If the other guy is going to swerve, the best thing for you to do is just go on straight and be this macho guy winner. Yay, Kevin Bacon, you saved the town. We can all dance now, because I think Footloose is actually about dancing. I don't think I've actually seen the movie all the way through, but I'm very familiar with that scene, once again, because of the game theory involved. I like game theory. Okay, here's my point. If you think the other guy's going to swerve, you should go straight. If you think the other guy's going to go straight, you should swerve. This is a very strategic game. It's strategic in that you want to think about what the other person is doing and respond to it, best respond to it. So how does this apply to economics? Well, you could think of firms as playing this game. Think of two rival firms. One of them, two firms that want to enter a market. To enter a market doesn't mean physically you enter, like here's a market and I walk in. It means I start producing a product that I plan to sell to a certain group of people. This takes some time. You don't just like, bam, now I can produce these things to sell to these people. It takes some investment. Once you make this investment, you hope to gain some reward by being able to sell a widget to a group of people who want widgets. So there's an economic game that's going on here, which is how many firms are going to enter the market. And you may know this from supply and demand. The more firms that enter, the higher the supply, the lower the price, the lower the profits. Okay, so you would much rather be the only firm to enter a market than to be one of two firms, because you're going to have to split the profits with that person. And in fact, the price, not just the profits, not just the quantities will have to be split, but the prices will go down. In fact, the prices could go so far down, you might lose money. The prices could go so low that your profits are negative because of the fixed cost of production. You may remember this also about introductory economics. There are fixed costs of production that you have to pay no matter what. There are some variable costs that you pay based on what quantity you produce. And you have no control over the fixed costs. You can change the variable costs as needed, as the quantity changes. Okay, this is a strategic game. How will people play? This is game theory, to make predictions about how people will play in a game. This is called the game of chicken. And behavioral economics has something to say too. It's actually a subfield of behavioral economics and also a subfield of game theory that's sort of known as, you put those two together, it's like a Venn diagram of behavioral economics and game theory. You get behavioral game theory. Maybe some of you have heard of it before, behavioral game theory. But what does it mean? It's basically just the study of how people actually play games, perhaps in a way that's different than the standard economic or the standard game theory prediction would be. So maybe the first thing we should do is analyze a game real quick. Let's use the game of chicken, kind of like it. And then think about how standard game theory would make these predictions. And then also think about what actually happens if you were to play this game. So can you see, hopefully you can see the, it's like a matrix, like a box of payoffs, where there's two firms thinking about whether they should enter a market. And they have to decide, I'm sorry, I don't know if entrance is the right word, but let's say they've already made the decision to enter. I think this is after the decision to enter. Once you've entered the market, you can expand your business and fight the other firm in a way that tries to make it so that they will not make a lot of money in the market. You can be aggressive. by fighting the other firm, high quantity, low price, that sort of thing. Or you could accommodate the other firm and say, well, okay, I know that there's going to be two people in this market and I should just be accommodating to them. I think I could have framed this as a market entry game where you either enter or you don't. I don't know why I chose to do. I think I saw this in a book I was using, to use fight and accommodate as the two choices. But let's think about the payoffs of the firms. We're talking about a game right now. There's two players, firm one and firm two. There are two actions that they could take. They could either fight or they could accommodate. That's what we'll call the two actions, fight or accommodate. And there are payoffs that they generate, just the result is what the payoffs will be given every possible combination of actions. And this payoff matrix is, this box here will show you what all of the possible payoffs are. So just to clarify, if both firms fight each other, they will end up losing $5 million each. You should think of this as the two tractors slamming into each other. That's the bad outcome. They both lose $5 million. How about if one firm fights and the other firm accommodates? Well, the firm that's tough and fights really gets a lot of payoff here. They have a high quantity of production and the other firm doesn't, and they get lots and lots of profits from it. They get $20 million. The other firm gets nothing. And this is symmetric, so it doesn't matter which firm is doing the fighting. If firm one fights, the other firm two accommodates, firm one gets all the money. If firm two fights and firm one accommodates, then firm two gets all the money, the $20 million. You should think of that as being the hero of the game of chicken, where you don't swerve and the other guy does. And then what about if they both accommodate? Well, if they're both accommodating, then neither one of them gains on the other. Neither one of them takes advantage of this opportunity to be aggressive. It's kind of like they both swerve. They both swerve out of the way and they avoid the confrontation, but they don't really profit as highly as they could. Okay, there's a huge temptation to fight if you think the other is accommodating. That's kind of a point here, the last bullet point. But of course, they want to avoid this case where they both fight each other and lose a bunch of money. No firm wants to lose $5 million. But if you think the other person's going to accommodate and make $5 million, that's a huge temptation to jump in and be the aggressive one and earn 20. So tell me, what is the game theory prediction of this game? What do you guys think? Anybody have any guesses? Or just answers? Has anyone had game theory? If you've had game theory, this is a problem someone might give you. Find the Nash equilibrium of this game. And so for my class, am I going to have you find Nash equilibrium? Not necessarily, but I will make you know a few concepts from game theory. And one is the concept of rationality, which is each player seeks to maximize their payoff given the strategies of the other players. This idea of rationality is what may guide you towards equilibrium in this game. So if each player is maximizing their payoff, given what they think the other player will do, what will happen? Did somebody have a comment? Michael says, it's definitely not 20-0. I think it's probably -5. Excuse me, -5. So Michael, you think, let me go back to this. Michael, you think the equilibrium of this game is for both firms to fight. And that's the game theory prediction, is that both firms will fight and both firms will lose $5 million. Is that rational? Is it rational for a firm to say, you know what, I'm just going to lose $5 million. Oh, well. I don't think it is either. So actually, I don't think that can be right. Thank you for guessing, though. I really appreciate the participation in the lecture, even though it's just through a chat box. It's something. Sierra says both accommodate. Let's think about that. So Sierra says, what if both firms choose to accommodate? Well, then they both get $5 million, which is a pretty good, I don't know why I put million here. That seems like a lot. 5 million, okay. Imagine these are giant firms, like giant oil companies or something, and they expect to earn a lot of money. Maybe that could be an equilibrium. We'll both just say they're happy with the 5 million. What do you guys think? We need to start talking about what it means to be rational given your beliefs and whether those beliefs are accurate. If you believe the other firm is going to accommodate and you're correct, the other firm does accommodate, is it rational for you to also accommodate? Emily says yes. Well, let's look at the payoffs, Emily. If you think it's a one-shot game, let's pretend it's a one-shot game. If firm 2 is accommodating and you're firm 1, your choices are to fight and get 20 million or to accommodate and get 5 million. You want the higher payoff. 20 is higher than 5. So actually, here's my point that I wanted us to reach this conclusion. Both accommodating is not an equilibrium. Both accommodating is not an equilibrium. And game theory would predict you don't do that. Now, if you were a max min, if you use the max min strategy, which was like to take the safest option, then it would be to accommodate, both players accommodating. But that's not an equilibrium, okay? Sierra, why are you saying wow? What happened? Did I do something? Are you, what's crazy? I want to know what's crazy.
I just thought both of them would accommodate, and
Okay, so Sierra, I'm glad you're saying this because you're thinking like a real person, aren't you? You're thinking behaviorally. By behaviorally, I mean, behavioral game theory, the intersection of behavioral economics and game theory was that we want to know what people would actually do when playing this game. And I think what you just said makes a lot of sense. You're saying this game is obvious. Both players should accommodate, and that's what should happen. They should both get 5. And that may be a good behavioral prediction because, oh, wait, no, wait a second, Sarah. I think maybe you didn't understand the game and the incentives. Think about it. If you're firm 1, let's pretend you're firm 1, and you think firm 2 is going to accommodate, right? Maybe because you think, of course, the obvious thing to do is accommodate. Everyone's going to accommodate. So let's say you believe that. If you're firm 1 and you choose to fight, look at firm 1's payoff in this column here. Can you see the cursor? If firm 2 accommodates, you get $20 million. It's a lot of money. If you accommodate, you only get 5. So when you texted, why would you want to lose? I don't think you quite understand the incentives because you don't choose to fight because you want to lose. You choose to fight because you think the other guy's going to accommodate and you can make $20 million. Yeah. And if you're correct that the other person accommodates, then it was rational. And in fact, it's an equilibrium. I didn't tell you what the equilibrium is yet. I'm telling you now. Equilibrium is for one of the firms to fight and the other one to accommodate. It's an asymmetric equilibrium. Can I type that here? It's an asymmetric, it's a Nash equilibrium. I don't need to put the word Nash, but it still is. Would it be a disadvantage to fight if the other accommodates, if there are multiple rounds of the game? Sure, perhaps, because if there are multiple rounds of the game and you fight, I don't know. I sort of think maybe you want to establish your reputation as somebody who fights. I think the real worry is that if you repeat this game, you're going to see both firms fighting because both firms want to establish themselves as the one who fights while the other one accommodates. How would you guys play this game? Let's pretend you only play it once. You're not going to play it multiple times. You just had to play the game once. How would you play? Would you choose to fight or accommodate? Anybody want to say? Oh, this watch I think is right. It says 1:15. I'd get taken advantage of. You would choose to accommodate? Yeah, okay. Emily would choose to accommodate. There's some risk involved here too, right? If you are particularly risk averse, I would say, yeah, that's a reason for you to choose accommodate. At least you know you won't lose money if you choose accommodate. If you fight, you might lose $5 million. And now Sierra says she would fight. Oh, she changed her tune. She realizes now she can get 20 million by fighting, and she wants to do that. But hopefully everyone can see that this is not quite the same as a coordination game. Because remember, in a coordination game, the incentives are to work together and all coordinate at a high level if you can. If you can't work together and coordinate at the high level, then you'll maybe settle for coordinating at the lower level. There's no coordination here, except for in it's sort of a bad type of coordination. I mean, I don't know. In equilibrium, it's sort of anti-coordination where you do one thing, I do the other. How do I know who's going to do one and who's going to do the other? If you can't communicate, surely you can't tell. I will say a game theory is kind of agnostic about how you get to an equilibrium, if it's possible. Mostly the concept of Nash equilibrium is that if you found yourself playing a Nash equilibrium, then you would continue to play it. You wouldn't have any incentive to deviate from that equilibrium. You would sort of be reassured that that's the best thing I can do is to play this equilibrium. Now, how do you get there is a hard question. It's an open question, really, in game theory. Okay, but my point of this game is to say it's not trivial to think about what the other player will do. And in behavioral game theory, this thinking about what the other player will do has to be limited by our own brains. We have to take in the fact that we don't think like computers. We don't think like sort of infinite strategists who, like Vicini, going back and forth an infinite number of times over whether you put the poison in front of you or in front of me. We have to develop some kind of rule of thumb. And in very, games that are even much more complicated than this, the principles of game theory often break down because people don't rationalize and make strategies that are so complicated that game theory is the correct tool to analyze the situation. Actually, behavioral game theory may be better to say, here are some rules of thumb that describe the way people play. Here are some rules of thumb that describe the way people make their beliefs about how others will play. And here are the things they actually care about. Maybe they care about stability or being safe or maybe being fair. Actually, that's included in behavioral game theory. This fact that people may care about fairness or altruism or whatever. So in the game of chicken, you're thinking about what firm two would do and where your belief comes from. It really matters. You could be introspective and say, I think the other player, I'll think about how I would play the game. And that's how I think the other player will play. They're going to be just like me. And then you form a best response to yourself. In other words, I think, if I'm looking at this game, I would choose accommodate because it's the safest thing to do. And then you think about what would I do as a best response to accommodation, and that's fight. So I actually choose fight. Instead of choosing accommodate, which would be the thing I would, like what would I do? Like one step of thinking is, well, I would choose accommodate. You go one step beyond that. You think that you're one step smarter than the average person and think, well, if the average person would accommodate here, I'm going to choose to fight. Or if instead you did some introspection and thought, well, I think the average person, the typical person here would choose to fight. So I'm going to choose to accommodate because I don't want to end up with -5. I'll choose to accommodate. So that's one example of a rule of thumb is this sort of introspective play and best responding to yourself. So, but at least that's an answer for where these beliefs come from. How do I think about how the other player will behave? There's no answer to that. You know, standard economics can't possibly tell you how you think other players will play. So that's an interesting behavioral question, I think. Let's go on. I'm glad that when I asked you, there were different people with different answers. Okay, let's. Wait, 115. Oh, we go to 145. We go to 145. I want to. Oh, Michael, good. Can I bring up your point? Wouldn't always assume the other person is doing that too. It's just a cyclical decision. That's right. So let me clarify, because it would always just go back and forth, fight, accommodate, fight, accommodate. It's that you do one step of introspection. Okay. So you're not like Vicini, who's always going back and forth to where the poison is. You just do the one step. You think, well, if it were me, I would not put the poison in front of me. I would put it as far away from me as I could. I would put it in front of the other person. And then I think that's what Wesley did. So let's use this rule of thumb for Vicini. He would not go through this infinite regression of where the poison is. He would just say, I think if it were me, I would put the poison away from me. So that's what I think you did, Wesley. I think you put the poison away from you towards me. So I'm going to drink the thing in front of you. Something like that. Okay. So that's just kind of a starting point for the real behavioral game theory that we want to do in this class. I want to teach you another model, another behavioral model. It's called the cognitive hierarchy model. And it says a little bit more specifically where these beliefs are coming from and how people make decisions based on these beliefs. I want to do that. And in this game, the game of chicken, it's a good starting point, but it's actually not a very good way to think about it in a deeper one. So we need a little bit more complicated game. How about we think about this game? Can I have 2 volunteers to play this game? Maybe I'll give you extra credit. Maybe I won't. I'll see. Just the first 2 people who chat and say they'll be willing to play. I'll play in chat. Okay, Michael and Kevin. Sorry, everyone else, you're too slow. Michael was first, so you get to be the row player. You choose either A, B, or C. And Kevin, you get to be the column player, so you choose X, Y, or Z. And your points will be the row player's points or payoff is listed first. So as an example, if Michael chooses A and Kevin chooses X, what will happen? Michael will get 10 points and Kevin will only get 1. Sorry, that's bad news for you, Kevin. You only get 1 point. That's how it works. You understand? If Michael chooses C, then we're going to choose the C row, and Kevin chooses Z, then we're in the Z row. Funny. Then you find this box here where C and Z meet, and it's 1,7. That means 1 point for the row player. That was Michael. He gets 1, and 7 points for the column player. That would be Kevin. He gets 7. So guys, how about private message me in chat what you're going to choose. So Michael, private message me A, B, or C. Kevin, private message me X, Y, or Z. Thanks, Kevin. I got Kevin's. Waiting for you, Michael. He chose A, and Kevin chose Z. So the answer is they each get 3 points. Congratulations, everybody. You both got 3 points. What happened AZ happened. Okay, guys, why? Can you tell me? Do you mind talking, saying why you chose A and why you chose Z in this game?
I was just thinking about the other players, like because the row is first. Like my opponent chose first every time. I was thinking, what is the best choice for him? He was gonna pick A. A is like the best for him, so I assumed that he would pick A. And I just looked at the zero. I just seemed like the best payout for me. So I figured that if he's gonna pick A every time, I'll pick Z every time.
I think you made a mistake. Look, if you think he's going to play A and you're the column player, you're going to get the second number. You're either going to get 3 or 6 or 1. So you chose Z, which is to give yourself 3 points. But if you had chosen Y, you could have given yourself 6 points. 6 was better than 3. You get what I'm saying?
Yeah, I get that.
If you think he's going to choose A, your best response would be to choose Y, but you choose Z. But that's okay. At least I got I heard about what you thought he was going to do. Okay.
Or maybe I just saw the payout on Z and I saw that. I don't know what it was. It just made the most sense. I was just looking at it.
Okay.
I couldn't explain.
How about you, Michael? Do you mind saying why you chose A?
Yeah, so I thought the same thing, that A was the best payoff for me, and I assumed that he would pick Y.
Mm. Wait, so
and-
you thought you were going to get 4?
Yeah.
But wait a second. If you chose B, you would have got 7. Okay.
Yeah, but then I just looked at the other payouts and saw the 0-0.
Okay.
I mean, I guess it doesn't make sense for him to ever do that, but I was fine with saying that. Like, I would say that, yeah, I don't know. It seemed like a safe pick for me, and I just thought that he would pick Y.
Aha. So safe pick makes sense, right? Because if you choose A, you get either 10 or 4 or 3. That seems pretty good, right? If you choose B, you get 0 or 7 or 6. What about C? Did you even consider choosing C?
No,
Why not?
because the only one that I could get, yeah, it has one payout. I guess the only thing it's superior to is if like B or C for the X column.
But then you
Is the
could choose
only
A.
way for me.
Yeah. So C is clearly dominated. So the word that I will use from game theory is dominated. The payoff for C is always worse than the payoff for A. You should never play C. If you're ever thinking of playing C, just switch to A instead, and you'll get a much higher payoff. So this is what we call one step of rationality that says, if I'm the row player, I should never play C because it'll definitely give me lower points. Remember where I said the concept of rationality is saying, I want to maximize my payoff given what I think the other player will do. Well, no matter what the other player does, I'm better off choosing A than C. Does everyone
I
see
kind of
that?
got too that when I was doing mine, I didn't want to do, because I had looked at it and I just forgot till just now. I didn't want to do a 7-2 because I wanted it to be kind of equal. Because like a lot of this class, it seems like a lot of the people are trying to always coordinate.
Yeah.
So it's like 4 and 6 is higher than 9. So it didn't matter to me.
Yeah.
What
I didn't make it worth real points. So, I mean, or maybe I did. I didn't say if I did. If I do, you both get 3 points, which is, I guess, maybe kind of fair. Okay, so this game, I made it to be complicated on purpose. I want it to be complicated because it's maybe a first real example of a complex strategic problem with complex beliefs. Thinking about what the other player will do is not easy in this game. I'm meant for that to be the case. I think, though, there is an element of rationality. The rationality is, what do I know at least the other player won't play? Kevin should have realized that he's not going to play C. Definitely C is not going to be played. And then you can think about, Michael could think about, for Kevin, will he ever play X? X means if you're the column player, you ought to get 1 or 0. You might get 12, but actually you'll never get 12. You'll never get this 12 because you know the other player is not going to get C. So actually, in this game, if we do this one step of rationality each, Michael should have known that X will never be played. And Kevin should have known that C will never be played. And because of that, they're really playing this smaller game where it's either A or B or Y or Z. Okay? Now, if you do another step of rationality, how many steps ahead am I thinking about what I think the other player will think? Just like Vicini and the poison. How many steps ahead are we going to go? If we go another step, then we can see actually B is better than A if you care about your own payoff, because B, look, gets you either 7 or 6, whereas A gets you 4 or 3. You may say, what about this 10? And I say, what about the 10? You're never going to get that 10. Just ignore that 10, and you'll see that B is better than A. I have this here. Can I show it to you? I will show it to you. Watch. Here. If we eliminate the strategies that are dominated, and remember, this is because a rational player will never play a dominated strategy, we get to this point where we can eliminate C using one step of logical, rational thinking. C will never be played. Look, it's just gone. See how it's gone? It was there, it's not there anymore. Because no one will ever play it. Well, the same can be said for X. X is a payoff that for the column player, you only get 1 or 0. That's clearly worse than these other payoffs. We can eliminate X. That was another step of rational thinking. Once we get to this game, we can look at these payoffs and say, well, B will give you 7 or 6 if you're the row player. A will only give you 4 or 3. Actually, B is better. B is a higher payoff than A. Therefore, I should not choose A. If I do another step of rational thinking, and the game gets down to this. And now, if the row player has done all of these steps, just like Vicini thinking about all the steps of the poison, if they get this far, then the row player would say, actually, I want this 4 instead of this 2. And this is the outcome. This is what game theory predicts. Game theory predicts that in this game, the row player will play B and the column player will play Z. Kevin actually did play Z, but for the wrong reasons. He chose Z because he thought the other player will choose A, rather than what game theory predicts is that every player is like Vicini and they'll think it forward infinitely into the future using rationality. If that's the case, they'll both come to this conclusion, oh, that this outcome must be B and Z. But it totally wasn't obvious, was it? Nobody would look at this original game, or at least none of you, looked at this original game and said, oh, I know what's going to happen here. The row player is going to play B and the column player is going to play Z. That's just the rational thing to do. No, it's not the rational thing to do. It's the hyper-rational thing to do when you're thinking of a rational player and then a rational player's response to a rational player and then a rational player's response to a rational player's and then a rational player, this sort of, okay, let me give you the official term. Common knowledge of rationality, okay? If both players have common knowledge of rationality, then they will automatically go through these steps of eliminating anything that they know the other players won't play until you arrive at BZ. Is this reasonable to expect real people to do this? I mean, it didn't happen. Michael chose A, and he had a good reason why. He told us why he chose A. It looked like a pretty safe thing to do and had a high payoff. Kevin chose Z, but for not the reasons that are described here. So is it reasonable to think that people actually have common knowledge of rationality? Yeah, I think we had unlimited time. Oh, I boned us. I don't know, is boned an appropriate word to say in a undergraduate class? I don't even know. Given enough stakes, I think people will often put in that much amount of mental effort. I disagree, Peter. I mean, I agree. It's a nice thought. You sound like a traditional economist. You sound like a theorist. That's what you sound like. Because there's always this fight between experimental people who study what real people do and then theory people who have these sort of grand ideas of what should happen. And sometimes the theorists complain that the experimentalists haven't fully explained the game and the stakes aren't high enough and it really doesn't matter what we do and therefore the experiment isn't a true test of the theory. Okay, I agree with you, Peter. Given enough stakes, you would put in that method. So let's give you a game, and let's make it real. I'm going to increase the stakes. I'm going to say whoever wins this game gets, 5 extra points of it. Either, I'll let them decide. They can have a free. No, I'll just give them. Yeah, sure. Five extra points on their homework. How about that? Is that big enough stakes? So should I tell you the game? I'm going to stop sharing. Yes. Or I can make it sort of first, second, third, fourth, fifth place, etc. Can I explain the game to you? We have 10 minutes left. This is an important game. If anybody's paying attention right now, here's the big incentive. This is real extra credit. Here's how the game will be played. Everyone who's listening and wants to play, and there's no cost. If you lose this game, you lose nothing. So you might as well play. You will choose a number between 0 and 1,000. This is like a guessing game, but it's no ordinary guessing game. I'll tell you more about the game later. Right now, I'm just going to tell you how the winner works. The person who wins this game will be the person whose guess is closest to 1/2 of the median of all of the other guesses, including theirs, of all the guesses. Okay? So I want everybody who's willing to play this game to must be private. If you send a public message, you're disqualified from this game and I will not count your score. And you definitely can't win the extra credit. So the way this game is played, give me a number between 0 and 1,000. And the winner of the game is the person who gets closest to 1/2 of the median guess of all the other players. In other words, I'm going to take everybody's guess, everyone who's playing, and we're going to put them in an Excel sheet or Google sheet and rank them from top to bottom. I'll take the one in the middle. That's what median is. I'm going to take that number and divide by 2. And whoever's closest to that will get 5 extra credit points and then on their homework. Big incentive. You should really try. According to what Peter said, is if the stakes are high enough, you'll think about the strategies and you'll understand and you'll know what to do. How many players? Everyone who's listening to me is playing. Michael, you want me to tell you how many participants are there in this classroom? Right now, there's only 15. A lot of people skipped today. They're going to be sorry because they missed out on a chance to win some real extra credit points. And I wanted to make it real, kind of because what Peter said, and make you care. Like, oh gosh, I really want to get the right answer here. And you still have a little bit of time, but I'm going to start inputting your answers now. I hope another condition of this game is I might make your answer public. Is that okay? If you're the type of person who's embarrassed by others hearing what you did, then maybe you should not play. Remember, it's the person closest to 1/2 of the median of all the other guesses. So I'm gonna take a second here to tabulate my answers. I will say your name when I have gotten your answer. So the first person was Nick. This is just the order in which you. I don't mean first as in like you win. Then I got Peter's. I might give you a little bit of credit just for playing. I might. We'll see. Amina, I got your answer. Grant. I got Alexandria. Emily. Fergus is playing. I got Fergus's answer. He was paying attention. Kevin is playing. It's going to be interesting. Brian is playing. Sierra. Sierra got fancy here with the decimal points. All right. I'm not sure why she added a decimal point, but she did. And Michael. So if I didn't say your name, that means I don't have your number. And once it gets, you have a little bit more time to play, but once, say like 1 more minute, you have 1 more minute to submit a number. If you haven't submitted by then, I'm assuming you're just not playing. How many people do I have? Something like 11. I have 11. And probably no one else is going to play. Isn't this an interesting game? Let's think about this game. Let's think about what's happening in this game. You all had to think about what the other people would do, didn't you? You weren't just thinking like, you know, what should I do? I'm a person who likes, you know, 420, so I'm going to say 420. Nobody answered 420, by the way. But you're not just thinking like, you know, what should I pick for no reason? Hopefully, you thought about what you thought everyone else would do. What would be a typical answer for everybody else? And then you took half of that. Because that's the game. The game is to predict what half of what everyone else is. And you see how this is like one step of thinking. You actually want to try to be 1 step ahead of everybody else. If everybody else thinks that the average will be 500, and so if they think the average will be 500, then they'll say 250, right? And if you think that, that's how other people will behave. You should pick 125, because 125 is half of 250, which is what people would assume if they thought the average would be 500. Peter, why did you assume that everyone else would do this? What are you talking about? What are you talking about? Was that meant to be a private message? Okay. I think the minute has gone by. Would you like to see the results? First of all, I'm going to rank them. I'm going to not rank them. I'm going to sort them by column B. And the median. You want to see? I honestly assumed a fair number would misunderstand the game. So I guess could be higher than game theory prediction of 0. Oh, excellent point, Peter. Peter just said, he just answered, what's the game theory prediction of this game? It's 0, or perhaps 1. 1 is also, 1 and 0 are both answers because they're both equally close to 1/2. Do you want to explain why, Peter, the game theory prediction is 0?
Because if you just keep going up in orders of belief, first, second, third, fourth, then you approach 0 with each one.
Yeah, that's right. Another way to say it is that if the prediction were anything other than 0, then people would respond to it by picking half of it. Like if you thought the prediction was, well, everyone's going to choose 10. 10 is the answer. We'll all choose 10. Well, that can't be the answer because someone could choose 5 instead, and that would be better. They would win. So, and that's true for any number. The only number that's in equilibrium, because there's no deviation that's profitable, is 0 or perhaps 1. So Peter's right. The game theory prediction is 0. But what will people actually do when playing this game? They're not going to pick 0. If you picked 0, you may think you're being really smart, but you're not. You're being, what you're being is a bad judge of others, of other people. Because 0 only makes sense if you think everybody is going to arrive at this equilibrium conclusion that we should all pick 0. And of course they're not, and they didn't. Nobody chose 0. Let me just share with you what people actually did. And we can all praise the winner. Who do you think won? Do you guys feel confident of your guesses? What do you think the average, the median was? Here we go. The median was 111. What is half the median? Half median is 55.5. Who is the closest to 55.5? It is Brian. Brian is the winner. Let's see your distance. Okay, equals absolute value of 55.5 minus your answer. This is how far away everyone was. Distance. Your goal. Here's your answer. Here, I'll say your guess, and here's your distance. Brian won, but just barely. Brian was only 9.5 away from half the median. Grant came in second place. Grant, you came so close. You went with 66. If you had gone 64, you would have won. You guys can see these answers, right? Yeah, you can. Third place is Peter with 42. And fourth place is Emily. Fifth is Fergus. So maybe I'll reward, maybe I'll give you guys a smaller reward, like first place, 5 points. You know, if I do that, first place we'll get 5, second we'll get 4, so on, just to sort of reward you from playing. And maybe I'll let everybody who played get 1 point. That would be nice, right? Just for participating, you get 1 point. But if you came in, if you won, that like Brian did, he gets 5. Congratulations, Brian. Can you? Oh shoot, we're running out of time. But Brian, real quickly, can you tell us how did you do this? How did you come up with this answer of 65? Are you there? Did you leave? It was random. Oh, dang it. I hate when people who win my games do it. They weren't even trying. They're just like, 65. It turns out to be the winner. How about you, Grant? You were pretty close. Did you have a reason for choosing 66? Star Wars. Execute Order 66. Yes, I'm a Star Wars nerd. I watched them all. I grew up watching the original trilogy, and I had Wicket the Ewok pajamas when I was a kid. And it was ruined for me when the prequels trilogy, I'm still bitter about the prequel trilogy. Okay. Yeah, I was born in 1980, the year that Empire Strikes Back came out. Okay. Oh, Peter, of course, give 42. I'm aware of the reference to Hitchhiker's Guide to the Galaxy. So that's a good one too. But you would have done better if you had chosen 50, say. Anyways, we ran out of time. But this game is perhaps one of the best games that questions how many steps of logical, rational thinking, not do I do, that's not what it is. It's how rational do I expect other people to be? That's what this was a test of. The people who guessed 125, like Nick, he was saying something about the rest of you. He was saying, I think the rest of you are not going to think ahead. They're going to think, what's the average of 0 and 1,000? It's 500. I'll pick half of that, and it's 250. Nick was assuming that the rest of you didn't do any advanced rational thinking. Right, Nick? I'm not sure. I want to put words in your mouth, but 125 is exactly what you'd pick if you thought on average or in the median, most other people would choose 250, which is what they would pick if they thought they would just kind of respond to random numbers, which is 500 would be the average. Okay, we'll talk about this later, but this game is the best example of showing this logical steps of thinking that is an important part of behavioral game theory, to think about how much do I really expect other people to do? How do I think other people will play? This game is a test of that, and we see it's very different. The choices went all the way down to 2 and all the way up to 500. So we'll run out of time. There is homework. There's homework due on Monday, and I'll give you some extra points for participating in this exercise. It's fun for me. Do you guys have any questions? If not, I'll see you Monday. Hopefully we'll know who the next president is by then. Thanks for participating, guys.
Have a good one.
Congrats again to
Appreciate you, Professor. Thank you so much.
yeah. Congrats to Brian. He's gone, but apparently the winner was the person who just chose randomly. Oh well. See ya.